Go.
It's 11:54.
Oh. Teacher.
Oh, what are you working on?
Solving systems and equations using elimination, but I don't know what the heck this is.
Oh, that's easy. Elimination is just the process of lining up two linear equations and adding them up to cancel out one variable and find the other.
That makes no sense. You want to help? You want to help me do this first
Sure.
problem? Okay.
So since the first two equations are already set up well, when you add the two x's together, they cancel out. And then you'd add 2y plus y, and you get 3y. And 13 plus 5 equals 18, so you're left with 3y equals 18. And then you would divide each side by 3, and you're left with y equals 6. So now that you have the y, you can plug it back into the first equation, and you get x plus 2 times 6 equals 13, and then you would get x plus 12 equals 13, and you'd subtract 12 from both sides, and you get x equals 1. The overall coordinate is 1, 6. The second problem is harder because we can't cancel out the x and the y's as we did in the first. So we'd have to multiply each equation by a number. So the first equation, you would multiply it by 2 to get 18x, and then you'd multiply the second equation by negative 9 to get negative 18x, and then you could cancel out those x's. So once you do that, you'd get 18x minus 16y equals 8 for the first equation. And then for the second equation, you get negative 18x plus 27y equals 36. And then you'd be left with 11y equals 44.
Oh, so now we just divide by 11 on both sides to find y. So when you divide by 11 on both sides, you get y equals 4. But does it matter which equation we plug the y in for?
No, you could do it into any equation. You'll get the same answer.
Okay, so I'm going to choose the first one, the first equation, which is 9x minus 8y equals 4. So when you plug in the 4 for y, it goes to 9x minus 8 times 4 equals 4. And it goes to 9x minus 32 equals 4. And then when you add 32 on both sides, you get 9x equals 36. And then you divide by 9 on both sides to get x, and you get x equals 4. So your final coordinate is 4, 4. Oh, I think I get this now. Let me try number 3. Oh, wait. The x and y's aren't lined up. So how do I do this?
Oh, all you have to do is subtract the y to the other side, and you'd get 3x minus y equals 11.
So once I change it to 3x minus y equals 11, you keep the other equation the same, right? And just start multiplying?
Yes.
Okay, so it would be 4x minus 5y equals 18, and 3x minus y equals 11. Then you multiply the first equation by negative 3 and the bottom one by 4 to cancel out the x's. So when you simplify that, you get negative 12x plus 15y equals negative 54 for the first equation. And for the second equation, you get 12x minus 4y equals 44. Then the x's cancel out. And it's 15 plus negative 4y, which equals 11y. And negative 54 plus 44 is negative 10. So to get y by itself, you have to divide by 11. So you get y equals negative 10 over 11. And then you have to plug it into one of the equations. So I chose 4x minus 5y equals 18. So it's 4x minus 5, negative 10 times divided by 11, and you have to multiply them, equals 18. And that simplifies to 4x plus 50 over 11 equals 18. Then you have to subtract 50 over 11 from both sides. but you keep the 4x. So it would be 4x equals 148 over 11. And then I got 148 over 11 by doing 18 minus 50 over 11, but the 18 was over 1, so you have to multiply that by 11, and you get 198 minus 50 over 11 equals 148 over 11. And so that simplifies to 4x equals 148 over 11. Then you have to divide by 4 to get x by itself. $148 divided by 4 is 37. And x equals 37 over 11. So the coordinate is 37 over 11 and negative 10 over 11.